In this lesson we will give the definition of machine learning and artificial intelligence. And we will briefly discuss the trend of the application of these techniques in medicine. We will then see the types of machine learning approaches. First we will see the distinction between supervised, unsupervised and reinforcement learning. Then we will analyze the difference between regression and classification problems in supervised learning. We define as artificial intelligence in a general way any programming technique to solve a problem, which has not been explicitly programmed for every possible case it will face. Let's take an example, the virtual chess or checkers player. This contains the rules of the game, some fundamentals of strategy and the history of some games. The software is then able to make decisions autonomously, based on these ingredients for each game configuration it will find. Within artificial intelligence problems we find machine learning. Machine learning focuses on data analysis and the ability to predict the future events based on historical data. When machine learning models become very complex and include several layers we speak of deep learning. The best known case of deep learning is that of neural networks. To demonstrate the interest of these technologies in the medical field, we can look at the number of scientific articles available on PubMed and published in recent years, which have exploited artificial intelligence in the medical field. The number is exponentially growing. For example, 75 articles on using artificial intelligence have been published in Nature only in 2019. This figure explains well the difference between supervised learning, unsupervised learning and reinforcement learning. In the case of supervised learning, each element is characterized by a label. The goal of machine learning is to predict the label for any new observation, for which the label is not yet known. In the case of unsupervised learning, there is no label associated with the observations. But the purpose is to regroup observations that are similar to each other or, better, to cluster them. In reinforcement learning, the process takes cues from past errors to correct future predictions. So, let's start to study different supervised learning methods. The first distinction is that between classification and regression problems. In classification problems, the variable to be predicted is a categorical variable that can assume several discrete values. For example, it can be a type or a condition or an alternative among possible cases. Conversely, in regression problems, the output variable is a numeric variable, either continuous or discrete. The figure shows an example of a classification problem. This considers a case in which the observations are characterized by two input variables x1 and x2 and in which the goal is to predict a binary label. In this case, it is represented in the figure by two different colors. The purpose of classification is to partition the plan x1, x2 into two regions, such that in one of these the number of green points is maximized and that of blue points is minimized and vice versa in the other part. In this way, each region is associated with the most present label and, when a new observation arrives, the green or blue class will be predicted based on the region where the point is located. In a more general way, in classification problems we want to associate a label to each input observation. For example, in the medical field we could have the clinical record of a patient as input. And we would like to associate a label with this clinical record, regarding the evolution of the patient. For example, we would like to predict whether the patient will be healthy or sick at the end of a treatment. Typically, to include the uncertainty of the prediction, the result is in terms of the probability of belonging to one class or the other. In regression problems, the goal is to evaluate the numerical value of the output variable based on the value on the input variables. Operatively, this can be done by determining the function y equals f(x) that describes the trends in the data. In this way, when it is required to predict a new value of e given its xi value, this could be done by calculating the value of the estimated function when using xi as input. All supervised learning models need a training phase in which, for example, the coefficients of the models are estimated on the basis of past data. In this way, once the coefficients have been determined, it is possible to apply the function to make estimates on future observations. Typically, the shape of a function is a priori determined, while its coefficients are estimated from the observations in the so-called training phase.